Hello everyone. In this lecture, we will discuss Dijkstra algorithm. Dijkstra was a Dutch mathematician who discovered this algorithm. Dijkstra algorithm provides the shortest path between the source vertex and any other vertex in a weighted graph. These are some notations which we'll use in this algorithm. S for source vertex, dv for the shortest distance of v from the source, pv for the parent vertex of v, t is the set of vertices of the graph traversed for finding the shortest path up to a certain moment, and u is the set of vertices of the graph still not traversed for finding shortest path up to a particular point, and wuv is the weight of the suv. So these are some notations. Now let us move to the algorithm. Now for each vertex v of vg, dv equal to infinity, it means we are going to assign a very large number to this distance, shortest distance of the vertex v. And pv equal to null, it means initially the parent of vertex is not assigned. The null value is given to the parent of a vertex, and initially the shortest distance of the source vertex is 0. T equal to phi, it means initially no vertex is traversed, so t equal to phi, it means this is a null set. U equal to vg, set of untraversed vertices, so this equal to vg means we have to traverse all these vertices. Now we have to choose the vertices from u one by one until u becomes empty. So while u is not equal to phi, u, the vertex from u having the smallest du, smallest distance from the source. So once we choose this, now we have to include this vertex into t. So t equal to t union u, and we have to exclude it from u. So u equal to u minus u. Now we have to find the adjacent vertices of u. So for each adjacent vertex v of u, dv is the existing distance, and du plus wuv, look at this, du is the shortest distance of u from source, and wuv is the weight between u and v, weight or mean distance between u and v. So it means du plus wuv, this will give you the distance of v through u. This is the existing distance, and this is the distance through u. So if this distance du plus wuv is less than dv, it means now the shortest distance of u will be this one, du plus wuv. So if this equation, this is the inequality satisfies, then you will update dv. So dv equal to du plus wuv, because now this is the shortest distance of v, and this shortest distance is through u, and the parent vertex of v will be u. If this condition does not satisfy, then no need to change, or the shortest distance dv will remain same, and you will choose the vertex u one by one until u becomes infinity. Once all the vertices are taken, then this process will be terminated. So now we take one example. So in this example, a is the source vertex. Now we have to find the shortest path for all these vertices from a. Now we apply this algorithm. So initially we write t equal to phi, u equal to set of all the vertices, and for all the vertices shortest distance is assigned as infinity, and for the source vertex this is 0. So there is t and u. Now if you we have to choose the vertex u having the minimum shortest distance. So here this is minimum distance is 0, and the vertex which we will choose is this is a. So t equal to a, this is t equal to a, and now we have to include a into t, so that's why it is t equal to a, and we have to exclude a from u. So u equal to b, c, d, e, f, g. Now we have to find the adjacent vertices of a. Adjacent vertices of a are b, e, and c. Here if you see, red color is used to represent the selected vertex, and green color is used to show the adjacent vertices of the selected vertex. So b, e, and c, these are adjacent to a. Now for each of these b, e, and c, we will calculate the terms which we have given in algorithm. Now dB, this is existing distance. dB is infinity. Now we will calculate dA plus W, means distance of B through A. So this is dA plus WAB. So initially dA equal to 0 and WAB this equal to 3. So 0 plus 3 equal to 3. Since dB equal to infinity, so infinity is greater than 3. So this condition is satisfied. Now you will update dB. So dB will be updated as 3 and the parent of the vertex B will be A. Similarly, DC equal to infinity, this is the existing distance, and dA plus WAC means distance of C through A. This is 0 plus 2, 2. So this condition is satisfied. So we will write DC equal to 2 and PC equal to A. This is the parent of C is A. Similarly, we will calculate DE, this is infinity existing distance, and distance of E through A, this equal to 0 plus 7. Look at this, A equal to 7, so 0 plus 7, 7. So this condition is again satisfied. So you will write D equal to 7 and parent of E is A. And this is the updated table. So here these three values 3, 2 and 7. For B for B it is 3, for C it is 2, and for E it is 7. So these three values will be updated in this table. Now from here we have to repeat the process and we have to choose the vertex having the minimum shortest distance, and the minimum shortest distance is 2, and the vertex which we will select is C, and the parent vertex is A. So it means first we will choose this edge AC, and this will be the shortest distance from A to C. So now go to the next. Here I have shown this in bold red lines, means this is the shortest distance between A and C. Now the selected vertex is C. So you will update T, you will include T, you will include C in T, so T equal to AC, and you will exclude C from U, so U equal to B, D, E, F, G. Now you will find the adjacent vertices of C, so D, F and G, these three vertices are adjacent to C. So again for these three vertices you will check the existing distance and the distance through C. So DD, this equal to infinity, the existing distance. If you go back, DD is infinity, this is the existing distance, and now you will calculate distance of D through C. So DC plus WCD, so you know DC equal to 2, so DC equal to 2, WCD means distance between C and this is 3, so 2 plus 3 equal to 5. Now this condition DD greater than DC plus WCD, this is satisfied. So this distance DD will be updated and you will write it 5, and the parent of D will be C. Now for G, DG is infinity, this is the existing distance. You will calculate distance of G through C, this is 8. So this condition is satisfied. So you will update DG, this equal to 8, and parent of G will be C. Similarly, you will go for F, and this distance is infinity, distance through C is 10. So this condition is satisfied. So you will update TF as 10 and the parent of F is C, and this is the updated table. Now from here, if you choose the vertex having the minimum distance is 3 and the vertex is B. The parent of B is A. So parent of B is A. You will choose this AB. It means this is the shortest distance between A and B. Now look at this. Here again, the bold lines in red color, these represent the path which we have already covered. So now from this point, the selected vertex is V. The minimum distance is, we have already checked, this is 3. So selected vertex is B. Now you will update T and U. B is included in T, excluded from U, and now you will find the adjacent vertices of B. So these are E and D. So again, this is the existing distance of D. D equal to 5, you will see here. D equal to, this is 5, this is the existing distance. Now you will calculate distance of D through B. DB, you know this is 3, and BD, this is 4. So 3 plus 4 equal to 7. Now this condition, look at, this is 5, this is 7. This condition is not satisfied. It means no need to update. No change will be there in the table because this condition is not satisfied. The shortest distance of DD is 5. So and through B it is 7, so we will not change in the table. Similarly for E, you will calculate this. You will calculate this is 7 and the distance through B is 8. 7 is less than 8, so this condition is not satisfied. So no change will be there in the table. So table will remain same. So this table is for the vertices of U only. Now here again you will choose the vertex having the minimum distance. This is 5 and you will choose the vertex D. So D and the parent vertex of D is C. So this path is called CD. It means the shortest path up to D is through A, C and C, D. So I will show here in this graph. So these are the vertices so far selected and their shortest path from A. And you will repeat this process again and again. As we have selected D, now you will include D in T and remove it from U. Now you will select the adjacent vertices of D. These are E and G. For E and G, you will calculate the distances through D. These are the existing distances, and these are the distances through D. So if this condition is satisfied, then you will update the table. Otherwise, you will not update the table. So here look at this condition is not satisfied, so no change will be there. Here again this condition is not satisfied, so no change will be there. So table will be like this. So from here now this minimum is 7, you will choose E and the parent of E is A. So now this path EA, this is parent of E is A, EA. So we will choose this AE, this S. So up to that point these are the selected vertices and the shortest path of these vertices. Repeat the process, include E in T and exclude it from this. Adjacent vertices of E is F. For F, this is the existing distance, this is the new distance. Look at this. This condition is not satisfied, so no need to change in the table. Now here, from here, this is the minimum. Now you will select G and the parent of G is C. So parent for G, look at this. This is selected. This is parent of G, C. So this CG, this edge will be selected. Now this edge is selected. So include G in T and remove from U. Now you have only one vertex F. F is adjacent to vertex F is adjacent to G. So we have previously we have selected this vertex G. So F is adjacent to G. Now DF, this is the existing distance and we have to calculate the distance through G. This distance is 10. Again no need, this condition is not satisfied, so no need to change the table. So this final we will have this table. Distance of F, shortest distance of F will be 10 and the parent vertex of F will be C. So means we will choose CF. So finally we will have this graph. Now T equal to A, B, C, D, E, F, G and U equal to 5. All the vertices are covered, U equal to 5. It means the process terminates. So now we have the shortest path of each of the vertex, each of the vertices of the graph from the source vertex, and these paths are shown in bold red lines. So in this way you can apply this Dijkstra algorithm to find the shortest path of each of the vertex of the graph from a given vertex, that is source vertex. So I hope that you got the concept of this algorithm and now you know how to apply this algorithm.